This is Mr. Hanna. Welcome to What the Format. So I did base function videos for absolute value, for your quadratic, and for your exponential function. I mentioned, at least with the absolute value function, that there's the transformed function. Yes? Well, all the functions transform with those four transformations. So let me show you how that works. I figured an example would be easier to see. You have a negative in all of these. Remember, if your a, the number in front of your function, is negative, that's a what? Reflection across the x-axis. So right here, you have a negative. So remember, that's your reflection across the x-axis. Now, you don't decide if it does that. The problem decides for you. Notice that in this case, all of the functions have the same negative, same a, same h, same k. Those transformations are the same. The only thing that's being changed is the shape that you're transforming. Recall, what's this shape? Right, a V. This was a U shape. And then this was that little right there. Okay? Now, there's your base functions. These numbers are changing the shape of that. So there's your reflection across your x-axis because the negative's there. Now, what if I took the negative away? Then there wouldn't be a reflection across the x-axis. And all the reflection across the x-axis looks as if these go down. So that now points down, that points down, this points down as well. Hopefully you're seeing that. Now, if you're not, here's what you do. Take these to desmos.com. Put them on desmos.com. Graph them, right? And then what you do is type this out just like this. Take away the negative, watch what it does. Okay? Put the negative back. Change this -1 or +1 to a -1. Watch what the graph does. And now you can play with it on Desmos, and you can change the numbers, and you can actually in real time see what that shape is doing. But you'll notice that the actual shape itself doesn't change. It's just the size or shape. Size of it, I should say. Okay? Shape is the same. The size does not change. Okay? Then your A, that 2. Guess what? 2 is greater than 1, so that's a vertical stretch. It doesn't matter that it's negative. Remember, negative is the reflection or not. You look just at the 2. Separate those, please. 2 is greater than 1. That's a vertical stretch. Okay? Now, it happens to be stretching it down instead of up. Remember, I said you can either stretch up or you can stretch down. So the -2 is stretching down, but it's still a stretch. All right? Then, look at that +1. +1 moves you left 1. Remember, it's opposite. A +1 is left 1. A -1 is right 1. Now that's only on the horizontal shift, only when you're talking about the x. What does that -3 do? That's right, it moves you down 3. Okay? There's your transformations. That's how transformed functions work. But notice, if you don't know the base function, you can't do it. Well, Mr. Hanna, this looks tough. I don't think I can remember all that. Well, guess what? There's a beautiful part. You don't have to if you're asked to graph the function. If you want to know what the transformations are, you can actually just graph out the parent function and then graph this on the same graph, and you'll see whether it moved left or right, up or down. If it got skinnier, that's a stretch. If it gets fatter, that's a shrink. If it goes the opposite way it was supposed to, down, then you had your reflection. You can see that in the graphs. Okay, let's do a quick example on it. So we got that down. Those are your transformations, which sometimes they'll ask you that. They just want to know what the graph did, but a lot of times they'll ask you to graph it. So let's graph this. So I have f of x equals, we're going to do this one, right? But I'm going to start with the parent function, the base function. So recall that the absolute value function, I've got it memorized. There you go. It's just your x, your v like that. That's what this is, yes? And I'm going to dash it so I can tell it different from my transform graph. So there, the dash version right there, that's your base function. So how about we make an xy table of this? So I go x, y. Recall that in your transform function, you want the center point. We take whatever's inside and we set it equal to 0. So x plus 1 equals 0. When we solve that, we get x equals -1. That's my center point. Okay, now I'm going to go up 1 from here. 0, 1. Down 1 from here. -2, -3. Okay, those are the 5 points I want to use. Now we use that skill that I taught you the other video of evaluating. So we're going to plug -1 in here. So I have -2, -1 plus 1 minus 3. That's going to be -2 times the absolute value of 0. See, I'm just going to do the math here. X is -1, so -1 plus 1 is 0. Now the absolute value of 0 is 0, so now that's -2 times 0, which is 0, minus 3 is minus 3. Okay? Now, I want you to try, pause the video, try plugging these points in. You need to plug these two in, see what you get. Plug those two in, see what you get. Now, these two should match and these two should match. So you can either do all 4 for practice, or you can do these two, and then I'm going to do them here real quick. I want you to pause the video. You try them on your own, and then unpause the video and see if you get what I get. So go ahead, pause the video. Okay, when you unpause it, here we go. Okay, so hopefully you saw that you substituted right. Where the x is, now you're putting 0. So now inside parentheses you do 0 plus 1. There's your 1. You can take the absolute value. Don't look at the -2 or -3. Recall that we take the absolute value first, because that's an exponent step in your forward PEMDAS. Absolute value of 1 is 1. -2 times 1 is -2, and -2 minus 3. These are both negatives, so do not subtract. Don't say it's -1 or 1, please. They're both negative, so you add them. 2 plus 3 is 5. Keep the sign, -5. Okay? Now I'm going to do the other one, hopefully. Now you'll see, I only have to change a couple numbers at this point. I'll clean up that -3. That didn't come out as well as I wanted to. So you got -2 times that number minus 3, and you're going to get your answer. So watch. Now instead of 0, what do I put in there? Ooh, a 1. Why? Well, because that's what the next number is. What's 1 plus 1? 2. What's the absolute value of 2? 2. Now you have -2 times 2, which is -4, and -4 minus 3 is -7. And then remember, these points mirror. If you don't trust it, plug -2 in there like I just did. Do the math, -3. Compare to see if you get the right answers. Now, how does that help me, Mr. Hanna? Well, let's graph them. Okay, we have our graph over here. Okay, -1, -3. So this point right here went, that center point, look, it went left 1, down 3. Does that make sense? Yes. Plus 1, remember, is left 1 and down 3. See how that worked? Now, what about the next point? 0, -5, yes? 0, 1, 2, 3, 4, 5. Okay? -2, -5 is over here. Now in this case, I don't need the other points. I can see what's happening. I know this is a B, yes? I can see that that does what? Well, how does that make sense, Mr. Hanna? Well, remember, it was a negative. Positives go up, negatives go down. You can see that reflection now. And then notice that the graph is skinnier than this one was. Just a little bit skinnier. Why? Because 2 is a vertical stretch. That's how you can see your transformations. This will work for this. The difference is you're a base U. You can plug those points in because it has the same center point. You can do the same thing here. Plug those points, do the math. Now, these points mirror. Doesn't happen here. You're going to have to do all 5 points. Okay? Now remember, if you're not sure you're doing it right, try it. Look on Desmos. Okay? If you're not doing it right, come back and watch the video again. Okay? Now I'll have another video momentarily that will do the squares and then one that will do the exponential function, so you get to see those. It'll be the same video as this. But I wanted you to see that the function itself doesn't matter. The process that you go is the same. Now the math you do is different. Don't confuse process with math. The function changes the math you do. But where you get your numbers and plugging them in and evaluating and graphing, that's all the same skills. And you can either do them or you can't. That's what the purpose of some of those other videos I gave you were. Practice that first, then come back here. If you try to do things out of order, you're only going to confuse yourself. All right, this has been Mr. Hanna. Thank you for watching What the Format. Happy mathing.